Hi guys, here's the video going over your Module 1 Geometry Test Review. So Learning Target 1.1 says I can draw a segment and measure its length. So number 1 says name line N in a different way. So let's look for line N. Here's line N, right here. So line N corresponds to this one that I'm highlighting in purple. And what we want to do is we want to name it in a different way. So to name it in a different way, you can pick any 2 points that are on that line and name a line using those 2 points. So I'm going to go ahead and go with AC. So I'm going to name it line AC. And notation is very important in geometry. We've talked about that several times. Since I'm naming a line, I need to have that line symbol above it. So there is another way to name line N. I'm going to erase this. Name a ray that goes through point B. So now I'm looking for a ray that goes through point B. So if you recall from your definition, your ray has an endpoint and it goes forever in one direction. So a point or a ray that goes through point B could be ray EB. Or I could even do DE, so I'm going to erase this, because I could have D as my endpoint, and it could go in that direction as well. So I'm going to put EB or DE, just in case you wanted both the answers. Either of those would be acceptable. Number 3 says to name any line segment. So to be able to create a line segment, you need 2 endpoints. So I'm going to pick 2 points that are collinear, so they're on the same line, and then I'm going to make a line. I'm going to name a line segment. So I'm going to go with EC. Now notation for line segment, you just put the line above it. But you have lots of line segments, so I just did EC. You could also have AE. You could have DE, you could have EB, you could have AC, DB, EA, lots and lots of different answers that you could have for naming the line segment. Alright, moving on. Name an angle that has ray EC as one of its sides. So let's highlight ray EC. So here it is in pink. So I need to create an angle that has ray EC as one of its sides. So I'm going to look at this one. So the one that goes through B. So if I'm naming that angle, that would be angle CEB. But you could also have a variety of answers. You could have angle DEC, so you could have this one. You could even have angle AEC, so this one. It's a straight angle. So you have a variety of answers. Alright, moving on. Number 5, find the midpoint of PQ. What quadrant is the midpoint in? So you do need to memorize the midpoint and the distance formula. So here's the midpoint formula. For your midpoint formula, I always just like to remember it as I'm adding my x's, dividing by 2, and for my y's, I'm adding my y's and dividing by 2. So I need to find the midpoint of PQ. So I'm going to go ahead and highlight PQ since that's my focus right now. My ordered pair for P is -4, -2. My ordered pair for Q is 2, 0. So now I'm going to plug in those 4 numbers into the formula for the midpoint. So I have -4 plus 2 over 2. And then I have -2 plus 0 over 2. Now I'm going to simplify those fractions. So -4 plus 2 is -2, divided by 2 is -1. -2 plus 0 is -2, divided by 2 is -1. So there's my midpoint. So I answered the first question. The second question says, what quadrant is the midpoint in? So if I were to graph this, -1, 1 is -1, so 1 to the left and 1 unit down. So that's where your point is. And then your quadrants, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So my point is in quadrant 3. That is not how you spell quad. It is in quadrant 3. So this question has two parts. It's finding the midpoint as well as determining what quadrant the midpoint is in. All right, number 6, finding RS. So finding RS. So I'm trying to find the length of RS, and that's going to be using the distance formula. So here's the distance formula. If you remember from class, I said you're subtracting your x's, squaring it, plus subtracting your y's and squaring it. Now the order you do the subtraction does not matter. So even though I write x2 minus x1, you could easily do x1 minus x2. So my ordered pair for R is -2, 3, and my ordered pair for S is 4, 2. So now I need to find the distance. So I'm going to plug in those values into the distance formula. So -2 minus 4 squared plus 3 minus 2 squared. So -2 minus 4 squared is -6. -6 squared is 36. 3 minus 2 squared is 1. 1 squared is 1. So the length of RS is the square root of 37. Now for this one, find LM and JK and determine if segment LM is congruent to segment JK. So again, you have to work through that distance formula. So I'm going to do JK in purple and LM in pink. So here's my JK. My ordered pair for J is -4, 4. My ordered pair for K is -2, 1. So I'm going to go ahead and find the distance. I'm going to subtract my x's. So -4 minus -2 squared plus, I'm going to subtract my y, so 4 minus 1 squared. So -4 minus -2 is the same thing as -4 plus 2, right? Because when you subtract a negative, same thing as adding. So that gives me the square root of -2 squared, which is 4, plus 4 minus 1 is 3, 3 squared is 9. So I have the square root of 13 for JK. Now let's do LM. So LM. So my ordered pair for L is -1, -1, 2, 3, 4. And M is 2, -2. So working through that distance formula, I'm going to subtract my x's, so -1 minus 2 squared, plus, I'm going to subtract my y's, -4 minus -2 squared. And again, you're subtracting a negative, so it makes that a positive. So -1 minus 2 is -3. -3 squared is 9. Plus, -4 plus 2 is -2. Squared is 4. So I get the square root of 13 again. So determine if the segments are congruent. I will write down the segments are congruent because they have the same length. And that length is the square root of 13. So one of the big thing in geometry is justifying. So you do your work for finding the lengths of those segments, and then you're using that math to support your answer. So the segments are congruent because they have the same length, which is the square root of 13. All right. So ST lies on a coordinate plane with S located at -3, 2, T located at 9, 6. Find the midpoint of ST and determine which quadrant the midpoint is in. So I'm going to go ahead and work through that midpoint formula again. So I'm going to add my x's, divide by 2, and then I'm going to add my y's and divide by 2. So negative 3 plus 9 is 6 divided by 2, and then 8 divided by 2. So that gives us the point 3, 4. And what quadrant is that in? Well, if I were to graph it, 3, 4, I would go 1, 2, 3, 1, 2, 3, 4, and that puts me in quadrant 1. So 2 parts for this, finding the midpoint and then finding the quadrant that it's in. Number 12, naming the angle 3 different ways. So there's a variety of ways that you can name an angle, just like there's a variety of ways that you can name lines and segments and rays and all that good stuff. You can name it just by naming the vertex. So if I name this angle using the vertex, my vertex is B, so I can name it angle B. I can also use the points on the angle to name it. So I have A, B, C. Or I can go in the other direction, C, D, A. And then those are the 3 ways you can name your angle. For constructing the angle bisector, I can't really show you how to do that in the video. I tried to put my stylus in a compass and write on my iPad, but it was slippery. So I can't really do that. So maybe I'll just kind of run you through it. You open up your compass, and then you're going to make these arcs. So you're going to make an arc on both the legs, or not the legs, both the rays. I mean, you can connect the arcs, or you can just do an arc and an arc. And then from each of those arcs, you're going to put your compass. So you'll put your compass pointy end right here, and then you'll make an arc on the inside. Put your compass pointy end over here, and you'll make an arc on that side. Now, like I said in class, you can tell when, you're not actually using the compass. So you can kind of see these 2 arcs don't actually look like nice arcs. So I would be able to tell that I did not use a compass for this. But I'm just trying to describe how to do it since I couldn't actually use a compass. And then from your vertex through the intersection, that is your angle bisector. So when you're taking the test, use the compass. Do not just do it like I did just now. You will lose points. But again, I just needed to explain how to make an angle bisector. Alright, moving on. Learning target 3, I can describe transformations in a coordinate plane using algebraic representations in words. So given point A is 5, 3, and A prime is 2, negative 4, write the rule for the translation from A to A prime. Alright, so I need to figure out some sort of rule to get from 5 to 2, and then another rule from 3 to negative 4. So since we're just working with this set of points, the best way to do it is by addition and subtraction. So I'm starting with my x, y, that's my point A. And then my rule is going to create the 2, negative 4. So what would I have to add or subtract from 5 to get 2? Well, that's 3. Subtract 3, so this will be x minus 3. And what would I have to add or subtract from 3 to get to negative 4? That would be y minus 7. So that is your rule, because if I take 5 minus 3, it gives me that 2. If I take 3 minus 7, it gives me the negative 4. True or false, a rotation is a rigid motion? That is true. If you recall, a rigid motion does not change size or shape. So that's actually answering number 16. How can you identify a rigid motion? After the transformation, the size and shape does not change. So a rigid motion does not change size or shape of the original image, of the pre-image, I should say. The rigid motion does not change size or shape. Should probably continue this, of the pre-image. Oh, can't spell. Rigid motion does not change, this is not grammatically correct, does not change the size or shape of the pre-image. Alright, so what is the image of negative 2, 3 under the transformation xy to 1/2 x and 3y? So I'm going to take negative 2, negative 3, and then just working through the transformation. So it's 1/2 times -2, and then 3 times your y, which was -3. So that becomes 1/2 of -2 is -1, 3 times -3 is -9. So there's the image. Alright, so now I'm taking this triangle ABC and I'm moving it under the translation x minus 2 and x plus 7. So to be able to do that, I'm starting with xy, and then it's changing to x minus 2 and y plus 7. So my xy for A is 2, 7. My xy for B is 4, -2. My xy for C is -3, -5. So to get the image, I'm going to take those points, and it's saying I'm subtracting 2 from my x and adding 7 to my y. So if I subtract 2 from my x, 2 minus 2 is 0. If I add 7 to my y, 7 plus 7 is 14. For this one, 4 minus 2 is 2. -2 plus 7 is 5. So just working through this rule. And then -3 minus 2 is -5. And then -5 plus 7 is 2. So this is the image of ABC under the translations. Let's go ahead and graph it. So 0, 4. Did I say 0, 4? It's 0, 14. 11, 12. So there's my new A. 2, 5. There's my new B. -5, 2. And there is my new C. Is the transformation a rigid motion? The correct answer is yes, because it is a translation. And we know that translations, rotations, and reflections are rigid motions. The only thing that is not a rigid motion is a dilation, because that changes the size of your pre-image. Alright, triangle MNP maps to triangle M prime, N prime, P prime. Write a rule for the transformation. Is it a rigid motion? Explain. So whenever I'm writing a rule, I'm always looking for a pattern. So what is happening to all my x's and what is happening to all of my y's? So let's start with the x's. I'm going to highlight the x's. So -2 to -4, 4 to 8, -2 to -4. So you need to ask yourself, what is happening with these x's? Well, these x's are being multiplied by 2, right? Because -2 times 2 is -4, 4 times 2 is 8, and -2 times 2 is -4. Now let's look at the y's. So I'm going from 2 to 1, 0 to 0, -2 to -1. So what's happening to your y's? Well, if you look at your y's, they're being cut in half. So 2 to 1, I'm dividing by 2. -2 to -1, also dividing by 2. So like I said, you're cutting it in half. So I'm taking 1/2 of y. So there's your rule. Now, anytime you are multiplying your coordinates by a number that is not 1 or -1, that is a dilation. So this right here is a dilation because I'm multiplying by 2. So this is not a rigid motion. Not a rigid motion. Because x is being multiplied by 2, and y is being multiplied by 1/2. multiplied by 1/2. Essentially what we have right here is a dilation. And if you recall from class, dilations are not rigid motions. All right, let's keep going. 1.4, I can prove a statement. So if AB is x minus 4, let's start by labeling x minus 4. BC is 2x minus 7. AC is 25. Find x, AB, and BC. So the segment addition postulate states that I can take those two pieces of segment AC and I can add them together and it equals 25. So that's exactly what I'm going to do. So I have x minus 4 plus 2x minus 7 equals, sorry, having some technical difficulties over here. So I have x minus 4 plus 2x minus 7 equals 25. Let me fix that. I can combine like terms, so x plus 2x is 3x. Negative 4 minus 7 is negative 11 equals 25. Add 11 to both sides, so I get 3x equals 36. Divide by 3, and you get x equals 12. So I have x. So now I can find AB and BC. So AB is x minus 4, so 12 minus 4 is 8. BC is 2x minus 7, so 2 times 12 minus 4, so that's 2 times 12, not minus 4, minus 7. I was going to say, it doesn't work. Let's try that again. So 2 times 12 minus 7, so that's 24, minus 7 is 17. So I have 8 and 17. Now another way you can check this is if I add 8 and 17 together, does it give me 25? It sure does, so that means I did it correctly. And as I said before, it was the segment addition postulate that allowed us to solve for x. So segment addition postulate. All right, last problem. So angle BOC is x plus 3. So this right here is x plus 3. Angle AOB is 4x minus 7. And AOC, so that's this, is 21. So the angle addition postulate states that I can take AOB plus angle BOC, and that's going to equal the larger angle, angle AOC. So we already have our answer for 23. It's the angle addition postulate. So now let's actually solve for x and angle AOB. So I can set up my equation. So x plus 3 plus 4x minus 7 equals 21. Combine like terms, that's 5x minus 4 equals 21. Add 4, so I get 5x equals 25. Divide by 5, and we get x equals 5. Now we can find the measure of angle AOB. Angle AOB is 4x minus 7, so that's 4 times 5 minus 7. So 4 times 5 is 20, minus 7 is 13, so it's 13 degrees. Don't forget your degree symbol, it's kind of important. Alright, so that covers all of the problems that are on the test review. I hope this video helps you get prepared for your first assessment. Alright, see you in class.